All right, here we go. Number 7 for a second time. You've got two objects, and they tell you where they start. They tell you that they're moving towards each other, and that object 1 is moving in a negative direction, and that they collide after a certain amount of time, 0.65 seconds. Oh, good. Last time I had 0.66 seconds. I'll tell you, be careful. One of the things people make mistakes, if you're doing this right along with me, is they'll use my numbers rather than their own numbers. So be careful of that. Because then, Mr. Cochran, it didn't work. Well, of course it didn't work on yours. Your numbers are different than mine. But, so just be cautious of that. Or, that's why I publish the videos and actually the work, so that if it's easier for you just to follow along and not write anything, you can do that and then go back and look it up, what went on. All right. So we need to do the Y for this one. And so this is number 7. So what must be true for two things to collide or to meet? You would think that, but couldn't just one of them be moving? Yeah. Okay. Not actually good thoughts, but not actually conditions. Think about if you want to meet up with your friend tomorrow. What do you tell your friend? Where and what time? For two things to collide, is that what you're going to say? For two things to collide, for two things to meet, they must be at the same place at the same time. If those two conditions aren't met, they're not going to meet. No matter how they're moving or anything like that, to meet must be the same place, same time. So that's the fact I'm going to start with. The two objects must be at same place, same time. Object 2 must be moving positively, since towards object 1, and it is moving negative since towards implies opposite. Alright, so when I look for the velocity of object 2, I'm going to look for a positive value, because for things to move towards each other, they have to be moving in opposite directions. Right? At least from some frame of reference, they're moving in opposite directions. And I don't think we're playing with frame of reference in this one. What else? What else can I think about with this one? Let's see. Well, we kind of already said that with them having to be opposite because they're moving towards. Right? But yeah, you're right. If they had this matching velocities, then they'd never get closer. That might be enough. That might actually be enough. Oh, I know what I might add. How about the faster object 2 moves, the closer to 25 meters they will meet, and in less time. I realized this morning when I started on these, I have an old copy of the Y's that I'm using on the board, so they look different than the ones that you guys were looking at yesterday. I'll have to fix this sheet. I forgot to update it. Does that make sense for the Y? Did I hit all my points? Understanding of the physics, didn't say how I was going to solve it, but show the path. Okay. Let's go on to the how then. I think I need a diagram to help me out. So I'm going to say 0 is here, 25 is here, 13 meters is here. Here's object 1. It's moving this way at 5.4. Oops. Is it okay? I took this direction as positive. Is that okay with everybody? Sorry, I just did this problem like 5 minutes ago, so I'm already in my head way down the road. So this would be 5.4 meters per second. Object 2 is here, and it's moving, let's call that V sub 2. They're going to meet somewhere here in the middle. We'll call that D. How about D1, 2? So we remember that they're both going to be there. Good with the diagram? Okay. So now I remember my first rubric point, which is start with a valid equation. So if I look at my equation sheet, this one is our main kinematics equation. It tells us all about where things are and such. So I'm going to use that one. So I'm going to start, I'll put it over here. D equals D naught. So where the position I end up at is the position I start at, and then that's added to my velocity and my time. My velocity times my time gives me how far I move, my displacement, and if I take my displacement, combine it with where I start, I know where I end up. That's what that equation says. I translate from math to English. So I know that these guys end up at D12. So this is going to seem like a really silly equation to write, but they end up at the same place. Right? Well, the way that ball 2 gets there is it starts wherever ball 2 starts, so D naught, starting position of ball 2. It moves at velocity 2 for some amount of time. And maybe I'll move that over just a little bit. There we go. And the way ball 1 gets there is it starts wherever ball 1 started. It moves at the velocity of 1 for the same amount of time. Oh, I could have put that in my Y, right? That the time should be, oh, we did in the first line. To meet up, they have to do the same place, same time. That's how I know the time is the same on each side. Now, just substitute in. I know this started at 13 meters. I don't know what velocity it's moving at, but I know it's positive. For me, this was 0.65 seconds. I know this starts at 25 meters. It's moving at negative 5.4 meters per second, and it moved for 0.65 seconds. And the only variable I have there is the magnitude of my velocity. That's part A. Any question on part A before I jump into part B? None. All right. Let's do part B. Part B. It wants to know where is that position. All right. So I can pick either side of this, right? Because they both equal D12. I'm going to pick this side because if I messed up the first side, at least I won't mess up my second answer. And then I just substitute in 25 meters. Whoops, I've got my meters there. You guys didn't yell at me. Plus and I get whatever position D12 is. I assume you guys don't need me to do the math. You're capable of doing algebra, right? If you're not, see me after school. All right, so onward and upward. On to number 8. Number 8, this Graham bullet has a speed of this, and they want to know what is the kinetic energy of the bullet. They suggest units of kilojoules, but if you wanted to change those units, you could always get rid of a little K and it'd be just joules, right? I tend to work in joules, but so we can always change that. So let's see. Number 8. I should probably start off showing what I know about kinetic energy because that's really the only concept in this problem. You know, sometimes we have pretty straightforward problems. So kinetic energy is about the motion of an object with inertia. The more inertia, the more KE, the more speed, the more KE, and I might add in here just to bring it back to the problem, the bullet has low inertia but high speed. Right? Good? Now in this one, they're trying to mess with you a little bit because what are our base units for inertia? What are our basic units? Nobody? We should ask our European friends. The base unit for mass. Well, because they use the metric system, right? What's the base unit for mass of something? Mass. How much mass something has? I want to go buy a bunch of salami. How do I know how much salami I'm getting? Yeah. Okay, so grams. Okay. And that's what they give us. They give us this in grams, but the base unit is actually kilograms. All right, not grams. That's where they're trying to mess with you a little bit. Just like our base unit for speed is meters per second, not kilometers per second. So be careful of that. We do need an equation here, and luckily we only have one for kinetic energy, so I think we'll use that one. One half the inertia of the speed squared. And so 1/2. Now they tell me the inertia is 9.5 grams. I know to convert from grams to kilograms, that's multiplied by negative 3, so that would be 9.50 times 10 to the minus 3 kilograms. My speed is 1.2 kilometers a second. I know to go to kilometers to meters, I need to divide by 1,000. So that would be 1.2 times 10 to the third meters per second, and that would be squared. And I'd end up with an answer in kilogram meters per second, which would be the same as the joule. And then if I wanted to do kilojoules, I could divide by 1,000, I'd get kilojoules, or I could just change my units to joules in the problem. If you change the units when you're in the actual problem, then it will reevaluate the answer based on that. So either convert this answer from joules to kilojoules, or change your answer box there to joules. Questions? Excellent. All right, so we're looking at number 12. And so right away I see I've got these actually five cars moving. There's one of them that isn't shown that we find out about later. And so right away I start thinking frame of reference, right? Relative motion, because I've got multiple things moving. So I want to show that I understand that stuff. So I would start off with something like all motion is dependent on the frame of reference. Time is the same between frames of reference, but everything else about motion changes. And by that we mean velocity and displacement. Trying to think if there's anything else. Guys, remember, you don't have to be working on this one, but don't be distracting. Okay? I know I'm easily distracted if I hear you, so try to keep it down to a low muffle if you're gonna, which is fine. Just, I'm easily distracted. I think that covers this one. Look back at A blocks. I think I said something else there, but my brain is already frying. All right, so relative motion. So I need my relative motion equation from here. So these two here in the middle. So I've got the velocity of AC equals the velocity of AB plus the velocity of BC. I have the velocity of AB equals the opposite of velocity of BA. Those are my two relative motion equations. And then I think it'd be good to kind of list out our facts and figures here. What did you guys answer for part A? You said the Earth? Okay. So I'm going to list what we have, the velocity. I'm going to use G rather than E for the Earth. If you look ahead, you'll see why. So I'm going to use ground rather than Earth. And let's go back to our diagram. Which way on our diagram do you folks want to call positive?
Right.
To the right? Even though we have two velocities that go to the left and only one that go to the right? Okay, we can go with the right. Go with the right. If I was doing it myself, I probably would go to the left just because I hate negative signs. But if it makes more sense to the right, let's go to the right. So A with respect to the ground is positive 12 meters per second. B was 0. C was negative 15 meters per second. And D with the ground was negative 20 meters per second. Those are all my facts and figures from the problem. And then, so lots of parts here. Which parts did you want to do? We can do any of the parts, but which ones do you want to do? B? We can do part B. Okay, so part B, it says, what's the velocity of A with respect to B? All right? So we're doing part B here, and we're looking for the velocity of car A with respect to car B. So that's going to be the velocity of A with respect to something plus the velocity of something with respect to B. The only thing I know A with respect to is the ground, so I'm going to put the ground in the middle here. And I know B to the ground, so ground to the B is just going to be the opposite of whatever B to the ground is. Right? That's this equation. So velocity of A to B equals plus 12 meters per second plus the ground to B. B to ground is 0, so ground to B is also 0. So I get positive 12 meters per second. Or positive means to the right. Are there other parts in the problem that you want to do? All right, so any other parts on 12 you want to do? Yeah. Sure. I know that if I use this equation up here, that velocity of G with respect to B will be the opposite of the velocity of B with respect to G. Let me write that. Okay, am I right over here? So I know the velocity of G with respect to B will be the opposite of the velocity of B with respect to G. Okay? And the velocity of B with respect to the ground is 0, and the negative of 0 is 0. Or negative 0 if you want. It would come out the same way. Yeah. Which isn't really a thing. That's why I didn't write it. But. So I also don't write units on 0 because 0 is unitless. Because how can you have a unit of nothing? Ooh, now we're getting like philosophical.
Should we do the last part?
Yeah.
I don't know. H, part H? Sure, we can do part H. I think this may be the last one we have a chance to do. Oh yeah. Alright, so H wants to know, we add this car, the Etzel in, so car E, and it is moving at 8 meters per second to car A, but it doesn't tell us which direction, does it? So, for part H, we can write the velocity of E to A equals either positive 8 meters per second or negative 8 meters per second. We don't know which one, right? Because it doesn't tell us, so we have to assume both. So I want to find out what? I want to find out V to D, E to D. So I want to find out the velocity of E with respect to D. So I do the velocity of E with respect to something plus the velocity of something with respect to D. The only thing I know E2 is A, right? So I have to put E to A here because I don't know E to anything else. That means I need the velocity of A with respect to D, which I don't know yet. So I better do a little aside over here and maybe figure out the velocity of A with respect to D. And I can do the velocity of A with respect to something plus the velocity of something with respect to D. Oh, I know A to the ground, and I know the ground to D, or I can find out the ground to D. So, velocity of A to the ground was what, negative 12? No, positive 12, right? Positive 12 meters per second, plus, well, the D to G was negative 20, so what's G to D? 20, positive 20. Which means the velocity of A to D. Folks, there's an exit ticket that you should be doing, especially if you're not interested in this problem. But it's live and you should get it done now. So now I can substitute it back over here. I've got to do this twice. I can do it with positive 8 meters per second. And then I've got positive 32 meters per second. And then I need to do it a second time with negative 8. Good? All right.